Imagine uncovering a creature so bizarre it makes you question everything you thought you knew about prehistoric life. Well, that's exactly what happened when paleontologists unearthed the fossilized remains of an ancient, pint-sized aquatic reptile in Arizona, a discovery that adds a fascinating new chapter to Earth's history. This little critter, which lived around 220 million years ago during the Triassic period, might just be the closest real-world relative to Scotland's legendary Loch Ness Monster. But here's where it gets even more intriguing. This isn't your typical long-necked giant. It's a miniature version that thrived in freshwater environments. The fossils were discovered in Petrified Forest National Park, a place already famous for its treasure trove of ancient artifacts. These remains belong to a previously unknown species within the Tanystropheid family, a group of ancient reptiles known for their extraordinarily elongated necks. The researchers behind the find introduced the world to this new species in a study published in Paleodiversity. They named it Akidostropheus oligos, a title derived from Greek and Latin roots meaning tiny spiked backbone. Why such a name? Because the fossils revealed vertebrae so small they could fit on the tip of your pinky finger, each adorned with a peculiar spike-like feature. Tanystrophids as a group are nothing short of remarkable. Picture animals whose necks stretch out twice as long as their bodies and tails combined. Some members of this family were diminutive, resembling modern-day lizards at just a few feet long, while others grew to impressive lengths of 16 to 20 feet. And their lifestyles? Equally varied. While some tanystrophids were perfectly adapted to aquatic habitats, gliding gracefully through water, others preferred life on land or may have even taken to the skies in brief gliding flights. It's this diversity that makes them such a captivating subject for paleontologists. But why does this particular discovery stand out? For starters, tanystropheid fossils have historically been rare in North America, with most findings concentrated in Europe and China. In fact, before now, nearly all evidence of these creatures on the continent came from marine, saltwater deposits. That's what makes Akidostropheus oligos so groundbreaking. It represents one of the first clear examples of a freshwater-dwelling tanystropheid in North America. According to the researchers, this suggests that these reptiles occupied far more ecological niches than anyone had previously realized. And this is the part most people miss. The site where Akidostropheus oligos was found wasn't just home to one type of tanystropheid. It contained traces of 3 distinct species living side by side. This level of diversity within a single location is incredibly unusual, especially considering that the fossils came from non-marine continental deposits. It's remarkable, the paleontologists noted in their study, because it points to multiple Tanystropheid taxa coexisting in a single habitat or closely related ones. What's also fascinating is how the fossils were uncovered. Researchers sifted through sediment from an area nicknamed Thunderstorm Ridge, using fine metal screens to separate tiny fragments from the surrounding material. Under a microscope, they identified the minuscule bones, so small that they're classified as microfossils. This painstaking process highlights the incredible effort required to piece together Earth's distant past. So, what does this mean for our understanding of prehistoric life? Simply put, it broadens the picture significantly. These Triassic reptiles weren't limited to specific regions or environments. Instead, they thrived across diverse landscapes and ecosystems. From swampy ponds to winding rivers, places like northern Arizona, once warm and lush, were teeming with unique forms of life. And while they may not have been as large or mythical as Nessie herself, these creatures offer a glimpse into a world far stranger and more complex than fiction. Of course, this raises some interesting questions. Could there be other overlooked species waiting to be discovered in similar locations? How might our perception of ancient biodiversity change if we continue finding such unexpected gems? We'd love to hear your thoughts. Do you think Akidostropheus oligos challenges existing theories about tanystrophids? Or does it simply fill in gaps we already suspected existed? Share your opinions in the comments below. For those eager to dive deeper into the topic, check out related articles exploring the evolution of long-necked reptiles and other astonishing Triassic discoveries. After all, Every fossil tells a story, and this one has only just begun to unfold.